Welcome fellow learners. Today we are going to learn about a prompting technique called as few sort prompting and its variant dynamic few sort prompting. We are going to explore how these techniques can be leveraged with Langchain's SQL agent to supercharge your language model with a specific task. So let's first see the agenda of this tutorial. In the first step, we are going to implement a simple SQL agent where we are going to utilize a multiple table SQL database, and we will see how this SQL agent perform with that. In the second step, along with the SQL agent, with the same SQL agent, we are going to add few sort examples and see does it give us any benefit over simple SQL agents. And in the third and final step, we are going to utilize dynamic few sort examples with the same SQL agent, and we will see how it is better than the fixed few sort examples and simple SQL agent. So let's also see what are the benefits of using these few sort examples. So these few sort prompting technique can help us by adapting our LLM to a specific task. So let's take an example of sentiment analysis. We want to do sentiment analysis on one particular task. So we can provide it few examples where we can give which kind of particular text data would be treated as positive sentiment and which particular kind of text data would be treated as negative sentiment. In this way, it can improve our accuracy. And also, these few sort prompting techniques can help us to improve accuracy for the complex queries. So let's say we are basically creating a chat with data kind of model, or basically you can say chatbot, where we want to chat with our SQL database. So in those cases, there can be complex queries which will be difficult for the language models to create. So in those cases, we can provide few examples of those complex queries, and our language model will adapt to those queries and will give us the better results. In that way, our accuracy will be improved. And we are going to basically implement these few sort prompting techniques using basically prompt templates. So what are the prompt templates? So prompt templates are basically the recipe for creating the prompts for the language model. So if we talk about a prompt template, how these prompt templates gets created. So there are basically 4 steps that are being followed in creating a prompt template. The first one is it would be having instruction what basically our language model will be going to do. So let's say on the right side, I have provided an example where it is basically I want to create a chat with data kind of model using this SQL database. So if you see in the top, the instruction are given as like if you are given an input question, first create a syntactically correct SQLite query to run. Then look at the results and run it on the database, fetch the results, and then finally give us the final answer to the user's query. So these kind of things will be treated as the instruction. The second thing that basically includes in prompt templates are few sort example. So in the bottom, if you see, there is an example given with question like provide the gender wise survival rate along with the age bins, and the corresponding example SQL query is written, which also looks like a complex query. So this type of few sort examples can help the language model to get better accuracy. These prompt templates also includes a specific context. So if you see in the middle, there is a context related to the table schema written. So like table schema is given over here, and the corresponding 3 rows from the table is also written over here. And the final 4th step, or you can say part of this prompt template, is the input user's question. So it will be the user's question in the natural language format. So let's say user want to find out how many total specific age groups are available in the data. They can basically ask these questions, and those questions will be included in this prompt. So this is the basically type of prompt templates that we create, and we are going to utilize these prompt templates in our further code part, and we will show you how these few sort prompting techniques and dynamic few sort prompting techniques can help us to get us the better results. So let's get started. So to showcase how this few sort and dynamic few sort prompting works, we are first going to implement a simple SQL agent. A SQL agent basically involves two major parameters. One is database and another one is language model. To get the database, we are going to utilize this SQL database class from Langchain community.utilities, and we will be using chinook.db. This database consists of multiple tables. So let's import this database. If you see, there are total 11 tables in the database, and the different table names are provided over here. You can get different table names using db.get usable table names. Like there are table names like album, artist, customer, and so on. We can also print the schema of these tables using db.tableInfo function. You can see the schema of the album table, like it consists of three columns: album ID, title, artist ID. Other tables are like artist, customer. You can see schema for all these tables using this db.tableInfo. Now we are having our database. We can now get our language model. For the language model part, I am utilizing GPT 3.5 Turbo model. I am basically using Chat OpenAI from Langchain OpenAI and passing my environment or basically OpenAI API key through my environment variable. I have saved this OpenAI API key in my system environment variable. I have also passed this temperature equals to 0 to keep randomness minimum. Let's run this cell and let's print out the LLM. And we can see it has different parameters that we have passed, like temperature is 0, OpenAI API key that we have passed over here also. So now we are having both the database and the language model with us. Let's implement agent. So for the agent part, we are going to use create SQL agent from Langchain community.agent toolkits. Let's run this cell. And in this SQL agent, as I have talked, the two major parameters are language model and a database. So these are two that we have seen earlier. Other three parameters that I have used is, first one is verbose equals to true to see what are the different intermediate steps that this SQL agent follows. Second one is like this agent type. There are different agent types are available in this SQL agent basically. If you see its description, you can see that other agent types are like tool calling, OpenAI functions, zero sort react description, and so on. So these basically agent type helps this SQL agent to follow basically one guideline. So like this OpenAI tools can be really helpful in our use case, like we are dealing with the SQL database. So it does have different tools like list tables whenever you want to list all the tables in the database. Get the schema of those tables. It has different function with it, like get table schema. Like it has also different functions like to fetch the query, to basically fetch the data using the generated query from the LLM, and also like checking the query if that query is correct or not. So these different kinds of tools are available inside this agent type. I will be using stream runnable equals to false so that we can get the number of tokens that this basically a SQL agent is utilizing and the cost associated with it. So let's run this cell, and then basically let's first see which particular prompt template this agent is using. So if you see, this is the prompt template that this SQL agent is using. So the instruction has been provided to it. The instructions are clear, like it need to first create a syntactically correct query, then fetch the data from the database using this query and look at those results, and then finally provide the answer to the user. It has also been given different instructions, like it must always double check the query before executing. Also do not make any DML statements, like do not make any insert, update, delete, or drop statements. So these are the instructions that has been provided to this agent. Now we will be using get OpenAI callback to basically get the prompt tokens utilized by this and cost associated with this one single call from the agent. So now we are having our agent. We can basically invoke this agent and get the results from it. So let's say I'm basically asking a simple query like how many artists are there. So it should basically use the artist table and get the count of all the artists that are available in the table. So let's run this cell and see how this particular agent is working. So if you see, it has first invoked this SQLDB list table to basically list down all the tables available in the database. So it has fetched all these tables. Then it is basically using SQLDB schema to basically get the schema of the required table. So it has thought of like only artist table is required. So it did not include all any other tables. It only included this artist table schema over here, and then created a query like a select count star at total artist from artist. So these are the basically query it has created, and then basically invoke this SQLDB query tool and fetch the result from it. So like it fetched, there are 275 total number of artists, and then passed it to the LLM again and got the final answer from it. Like there are total of 275 artists in the database. Now if you see, it has used language model 4 times, it has requested 4 times, and it has utilized 2702 total tokens, out of which 2641 were the prompt tokens and 61 were the completion tokens. So completion tokens are basically these tokens, that this output result that it has generated, the query it has generated, this one, and these are the basically generated tokens that it has been used in this completion token. So in this way, we can implement a simple SQL agent and get the result from the database. Okay, so now we have implemented a simple SQL agent. So next thing is, we are going to implement the same SQL agent using few sort examples. So what are these few sort examples? As I have explained earlier, these few sort examples are basically the examples through which we want our language model to adopt to the particular task that we are asking it to do. So in our case, we are having SQL database with us. So we want our language model to first create a syntactically correct query using user's natural language question. So to get those queries with better accuracy, we will try to give our language model we will provide it few examples. So as you can see, I have listed down these few examples over here. So let's say this one is find the total duration of all tracks. So I have given it as an example, like select some milliseconds from tracks. So it will sum it all on the milliseconds of the tracks. So in this way, model will be better able to adapt to the particular task that we are going to ask it to do. These queries can also be complicated or complex. So we can provide those complex queries also. Like you can see this query a little longer and a little bit complex than the previous queries. So in this way, model will be able to know what kind of complex query that it could be basically asked. So this way we can provide few sort examples. To implement these few sort examples, let's first run this cell. So if you can see, I have provided 10 different examples to this language model. I have stored it in this basically examples list, and I will utilize this example list to basically in our prompt template. So when we are going to implement this few sort prompting in the same SQL agent, we would need this few sort prompt template from Langchain. So Langchain basically provide different types of prompt templates. Few of them are like, one is few sort prompt template, another one is prompt template. So for the few sort prompt template, we are going to utilize these same examples. And if you see, it's basically the different number of argument that it requires. This one is basically fixed few sort prompting technique that we are going to first implement using in this SQL agent. So it requires basically few examples in it. So we have, as you have seen, like we have used 10 examples over here. So we will pass 10 examples to this few sort prompt template. Another one is like we are going to pass an example prompt to it. So example prompt would basically give us insight, like how does basically these examples are written. So like there will be input will be the user's query, and there will be generated SQL query. So SQL query will be like this, like how many employees are there. SQL query will be select count star from employee table. So this way it will be provided an example. And the next thing is, there are few input variables are also there. If you see the prompt, this is the same prompt that we have seen earlier. This prompt is same, The only difference would be like after this, there will be these examples, these few short examples will be appended to this prompt. So we will see this further, how this how we are going to totally define this prompt. So if you see in this prompt, there are few input parameters that it requires. One is dialect. Dialect would be like SQLite, that we want to generate it in SQLite query. Second one is top K, like how many total results that we want this language model to basically generate. We don't want it to generate a lot of results, so we will basically limit it to this top K parameter. And one another is like input. Input, you already know, input will be the user's question that we are going to pass it. So there are few other parameters, prefix and suffix. Prefix is this same prompt template. A prompt, basically you can say, that we are passing. This is system prefix. As you can see from the name, system prefix basically defines the prompt that is being going to pass to the system or the language model. So it only for the purpose of model to know what are the instruction that we are going to pass to this language model. And suffix, we can also assign any suffix over here, but we do not need for now. These suffix could be like what you want this model to do after you have passed few examples to it. So let's say this is the system prefix prompt, and after this we have appended these examples, 10 examples to it. And after that, let's say we want, even after this, we want language model to think about it and then again look into the database and then look into the database schema and all. Those kind of suffix instruction we can pass to this basically few sort prompt template. So this way we will create our few sort prompt template. Let's run this cell. Now we are having our few sort prompt template. So as we are already using basically OpenAI tool type of agents, so OpenAI tool agent requires input in the form of chat prompt template. So for that purpose, we are going to import this chat prompt template from Langchain core.prompts, and this in chat prompt template, we are also going to pass few inputs to it. So this system message prompt template is basically few sort prompt that we have already created. This is basically instruction to the system or the language model, and we are going to provide it an input like this, like human is basically giving input to the language model in this format. And the third one is agent scratchpad. Agent scratchpad is nothing but basically a notepad for the agent, or you can say language model. So it will remember what different function or tools it has called in the previous step and other things. So let's run these cells also. Now we are having our complete prompt. So let's first print out what it does basically have. So it is having basically all the input variables that we have passed to it. It is also having all the examples that we have told it to have, those 10 examples, and also then our system instruction that we have passed to it, like this prefix of the basically prompt template. You are an agent designed to interact with the SQL database. This complete prompt template. So this is complete prompt that we have passed to it. So let's generate a prompt on the basis of the question that that user might ask to this basically language model. So let's say we are using this full prompt, this that we have basically initialized over here, and this is the user's question, like how many artists are there. Top K is the same, the number of output that we are going to limit. Dialect is SQLite, and at the start agent scratchpad will be null. So let's run this cell and see what prompt it will basically generate. So if you see at the start, it is having this same prefix that we have seen earlier. This system prefix is at the start. Next, it has basically embedded all the 10 examples, these 10 examples into it. And after that, it has passed the user's question in the form of this human key value pair. So in this way, complete prompt is being generated. Now this complete prompt is then passed to the language model. So for that purpose, we need to basically change a little bit in our SQL agent that we have created earlier. So over here, if you see, we have added another parameter. So now the prompt will be custom prompt that we have generated. So this custom prompt will be passed to this agent, and once user asks a question using this full prompt, it will invoke this full prompt and generate the complete prompt and then pass to this language model. So let's run this cell. Now we are having our agent with few short examples. So let's run the same query that we have run in the previous agent, which was having no few short examples. So let's run this cell and see how does it work. So if you see in this step, this agent only required to ask language model 2 times. And if you see in the previous step, when we are having no few short examples with the agent, it asked language model 4 times. And the total number of tokens that it utilized is 2702. And if you see in this time, when we are using few short examples, it is utilizing only 1731 tokens, which is around 1000 tokens lesser than the agent without few short example. So what is different here? Like, as we have already provided few short examples to this agent, it already know what kind of queries it can create based on the user's question. So here, if the query is related to the examples that has been already provided to the agent, it need not to list down all the table names and then basically print out the schema for those tables, because the query is similarly related to the examples that we have already provided. So those two, you can say, basically request to the LLM or the language model has been reduced. Now the two requests that was basically used are, one is to generate this database query, this select count star from artist, and once it fetched the data from the database, it next asked language model to get the final answer for the user. So it generated this. There are a total of 275 artists in the database. So only 2 times it needs to basically pass prompts to language model, and the total number of tokens utilized by the language model are reduced significantly. So you can say using few short examples are clearly helpful in the case where we want our language model to adopt to particular task. So now we have implemented our SQL agent with few short prompting. So next we are going to implement same SQL agent using dynamic few short prompting. So what is this dynamic few short prompting? So if you have seen, we are using 10 different examples as few short examples, and we are passing all those 10 different examples. Even the query doesn't require all those 10 different examples with the language model. So as we have asked this language model or agent, like how many artists are there, so we might need only 2-3 queries of all these 10 different examples. So like we might need this query, like how many employees are there, so it get to know, like we can create a query where we can get select count star. But we might not need these kind of queries where like a long basically complex queries, a lot of different queries. So in this way we are basically providing a lot of tokens to language model, which might not be necessary for different users query or users question. So for that part, we are going to utilize a RAG based approach over here. So what we are going to do in this RAG based approach, we will first create embeddings of these examples. So let's say all these 10 examples, we will create embeddings for all these 10 different examples. We will save them, and at runtime, whenever user asks a question, we will first run a similarity search. We will find out top 3 or 5 similar examples as to the user's query, and we will only use those top 3 or 5 users examples with the prompt that we are going to pass to the language model. Okay, so for that purpose, to get the embeddings from these examples, we are going to utilize OpenAI embedding model. So for this part, we are using text embedding 3 small model. So let's run this cell, and it's like same. We need to get our OpenAI API key and pass it over here. I have used the same OpenAI API key as I have used for the language model. Now we are having our embedding model. So if you see this embedding model, we are having this model. If you can see different parameters of it also, like there is total of context length of 8191. We cannot pass context length more than that. And the output of this embedding is like, we can also basically invoke these embeddings. You can see, we can basically, I think invoke function is not there. I think there is embed query function is there. So we can embed query and then pass our input to this. So let's say we can pass any text input to this, and we can get output from it. Let's see what is the number of embeddings, what is the size of embedding that it produces. So I think it is basically the kind of a model which provides around 1536 basically the embedding size. So there are different models for this available. There are open source models are also available for the to fetch the embeddings from the text data. I have used OpenAI embedding. In OpenAI embedding also there are different, like its previous version, V2 version is also available, which is basically text ADA002, and its even large model is also available. Cost is different. You can check for the pricing in OpenAI page. So okay, now we are having our embedding model. So next we will be implementing the similarity search model. So for the similarity search, I will be using this FAS. FAS is basically Facebook AI similarity search library. It is basically used to compare embeddings of different text and fetch the similar text as an output. So we are using FAS, and then we will be using this similarity semantic similarity example selector. So we will use this class semantic similarity example selector. We'll pass these arguments. Let me explain these examples. So let me explain these basically parameters. So the first parameter is example. This is the all the 10 examples that we have seen earlier. Embeddings is the basically the embedding model that we have seen, this OpenAI embedding model. FAS is basically similarity search library. K equals to 3. It means like we are going to only fetch top 3 matched similar document or similar you can say these examples. And input keys will be basically we are only going to pass input which will be the user's question. So let's run this cell, and for an example, let's see how does this basically gives us the output, this example selector. So let's say we are asking it this question, how many artists are there, which the same question that we have seen earlier. We can pass other argument like what kind of search type we are going to utilize. There are different algorithms are there, like cosine similarity, MMR, maximum marginal retrieval. Let's use this similarity search type, and let's run this cell. Now you can see it has fetched top 3 documents from the data, or top 3 examples from the data. The first one is like for this question, the input for this question, how many artists are there. It basically utilizes first this one, list all artists, and it got like select star from count. And let's see for the second one, find the total number of albums. It utilized this select count distinct album. The third one, it utilized how many employees are there, and it fetched like select count star from employees. So in this way, it reduced our total of number of examples only to 3, and which are basically related to this user's question. So to implement this dynamic few sort prompting, we are going to make some amendment to our previous few sort prompt template and the chat prompt template that we are going to pass to the language model or the agent. So in the few sort prompt template, as you have seen earlier, we were directly using examples as an input to it. Now we are only passing this example selector. So this example selector, we are passing it to this, and this example selector instance will run at the runtime. So user will basically ask the question. It will pass to this example selector. It will fetch the top 3 matched similar examples from the basically the saved embedding data, and it will provide it to the next part of the agent. So and other basically parameters are same as we have seen earlier. So let's run this cell. Now we are having our dynamic few sort prompt. The second one is chat prompt template is same. The only difference is like now we are having only this updated dynamic few sort prompt over here. Earlier we were having the few sort prompt which was fixed few sort prompt. So let's run this cell. Now we can basically get just gist of basically how this full prompt now will provide us the result. let's basically ask the same question that we are seeing for now. So let's run this cell, and if you see, the initial system prefix is same till here, and the queries that we were seeing, or the examples that we were seeing, that we have provided as an few sort examples, now reduced to only 3. So this way it has basically utilized or reduced a lot of tokens. We can now implement our SQL agent using this updated full prompt. We will run this cell. Now we are having our dynamic few sort agent. So let's run same question so that we can compare it with the previous agent. So now we can see how does this perform. So you can see the results. So the sequence of asking different tools using this agent is somewhat similar to the result that we have seen with the agent with the few sort prompting. Like it asked first to run this generated SQL query directly using this SQL DB query tool or function, and then it asked language model to generate the final answer for the user. So it's same as we have seen with the agent with few sort prompting. The only difference is that the number of tokens, the number of prompt tokens used or utilized by this agent. So if you can see, the number of prompt tokens it has used is 1281, and the prompt tokens that has been utilized by the agent with few sort prompting is 1701. So it's around 400 lesser than the agent with the few sort prompting. With the help of dynamic few sort prompting, we can clearly reduce the number of tokens we need to pass to the language model. Great. So we came up a long way in this video. We first get our database and the language model. Then we have utilized those database and language model to basically implement a simple SQL agent using Langchain. Then we created a SQL agent using few sort prompting technique. And then we finally created a SQL agent using dynamic few sort prompting. We have seen how these few sort prompting and dynamic few sort prompting can benefit us, how this can help us to get the answer to the complex queries. We can get our language model to use lesser number of tokens and other benefits. So I think we have completed this tutorial on few sort prompting and dynamic few sort prompting. In the next video, I will basically create a tutorial on how to create a custom agent using Langchain. So yeah, thanks for making till the end of this video. Goodbye until the next time.